Hi everybody, today we're going to talk about the geometric series. And a geometric series, so this is one example of one, right? 3, 6, 12, 24. To be a geometric series, the pattern has to be that you're multiplying each number by the same thing over and over again to get from one term to the next. So think about what number we're multiplying by to get from 3 to 6, from 6 to 12, 12 to 24. And hopefully you're coming up with the pattern is that we're timesing by 2. That's all it takes to be a geometric series, is that the pattern to get from one term to the next involves multiplying by the same number over and over again. And then we could come up with a general term for this. We started at a 3, and we timesed it by 2 just once to get from here to here, and then we times 3 by 2 twice to get from here to here, times 3 by 2 3 times to get from there to there. So we would let this just be to the n. And we're just going to, here's the series notation. We're going to sum that up. And because we want our, I'll put an infinity here because we're talking about infinite series, and I have the 3 dots. And where would we start? What would our first n value be? Well, you have to think, what n value would you need it to be for your first term to be just a plain old 3? And the answer to that is 0. 2 to the 0 is 1, times 3 is 3. Okay, so geometric series have this. So geometric series have this general form. You're going to sum an infinite number of things. Sometimes this will start at 1 or 2, but I'm just going to put a 0 in there. That's what our example just had. And then we've got this a, and then we've got r to the nth power. Okay, and that r is called the common ratio. Okay, so this common ratio is the one that you multiply by repeatedly. You should have heard the term common ratio before. If you haven't, I'll write down actually I think I'll write it down a little bit later for us. I'm running out of room up here. So would you say that this series is going to have a finite sum? Think about the numbers that we're generating, and if you add them up, do you think that sum is going to be finite, or do you think it's going to be infinite? I would say the series is not going to converge because the numbers, the terms I should say, are getting larger. And we had the same common theme here with the ratio test, using a ratio to see if the terms were getting smaller. This one, we're going to think about what would r have to be for terms to be getting smaller. And I think some of you, I'll let you think about that for a minute. But we would want to recognize this general series form, and I guess I'll write it again here. It was pretty small up top there. There we go. And we're going to say that this sum converges when this common ratio is less than 1, because if you multiply by numbers whose absolute value is less than 1, the numbers get smaller. Think about multiplying things by a half. They keep getting smaller. And then this will diverge when r is greater than 1. Now, with the ratio test, we had a really big issue with 1, right? That was when the ratio test failed us. It was inconclusive. We had to put those hokey question marks on our interval of convergence. But I want you to think about a series, like let's just say the series, the most general series we can have here, n equals 0 to infinity of 1 to the n, right? If that's our series, when we plug in a 0, we get 1 to the 0, which is 1. If we plug in a 1, 1 times 1 is 1. If we plug in a 2, 1 squared is 1. If we plug in a 3, 1 squared is 1. And I mean, can you picture just adding up a bunch of 1s? I mean, does it seem like that's going to be finite? And to me, no, it does not, which is why I love the geometric series test, because we don't have anywhere it's inconclusive. If r is less than 1, we're going to be summable, and if not, we won't be. Okay, we'll diverge when r is greater than or equal to 1. Okay, so this is, like I said, one of my favorite tests because this is never inconclusive. Unfortunately, we can only use it if the series is geometric. If you've got a common ratio that you're multiplying by every single time. And it looks like something in this form. Okay? Mine, I left off my A. Well, I don't have an A out there. Okay, so let's go ahead here and talk about that we will be able to sum the series if their R is less than 1, and there's actually a formula for that. So this goes right along with E, sine, and cosine that you are expected to be able to sum. You recognize them from a written out series, from series notation. You know their general terms. We want to be able to recognize a geometric series, finding an R that's less than 1, this idea that it's multiplying by a common ratio, want to recognize it. And then there is a sum formula. You take the first term over 1 minus R. Okay? And I think I've got a couple examples. Let's go ahead and try just 2 of them. And your job is just to say, if the series sums, and if it does, find the sum. Okay, so make sure you've got that. The first term you have to figure out, and 1 minus R. Okay, but this is only the sum formula if R is less than 1. Otherwise, it doesn't sum. Okay, so let's try it. In this case, you should be kind of pausing, seeing if you can pick out what R is. And if R is less than 1, you're going to find the sum. If it's not, you're going to say the series diverges. Okay, the thing that keeps getting multiplied by over and over again, like here it'll be to the 0, here it'll be 1 copy, here it'll be 2. When you put the 2 in, 3, you'll have 3 copies of that. This is your R. So R is 7/3, and the absolute value of R is 7/3. And we want that to be, that's not less than 1, that's greater than 1. So we'll say that this series is not summable. R is too big. In this one, now remember your R just has to go up by 1 power. So when we plug in a 1, it'll be to the 0 power. Plug in a 2, it'll be to the first power. Plug in a 3, it'll be the second power. So this still just keeps, as you plug in 1, ends go up by 1s, you'll just be getting 1 extra copy of 3/4. So this notation, don't let it intimidate you. That's still our R. And 3/4 is less than 1. So this is going to converge. This series will have a finite sum. And we are now supposed to find it. Okay, so we need 2 things. We already found R, 1 minus, so I'll put our R in. And then we need the first term. So take a second to figure out what the first term would be. And I'm getting 1 minus 1 is 0, 3/4 to the 0 is 1, 1 times 1/3 is 1/3. 1/3 over 1/4 equals 4/3. So an infinite, this will sum. We can sum that series, an infinite number of terms, and they're basically going to sum to 1 1/3. Okay, kind of fascinating. All right, and you can see like the ridiculousness of, if you tried to sum like our initial series. If we're going to sum that, our first term was 3, and our R was 2, and you get that the sum is -3. How can all these positive numbers sum to -3? So the sum formula is completely bogus and ridiculous if the R is not less than 1. Okay, folks, thanks.